Okay, hey, we're going to try a new format here today. I think it should work okay, though. What we're going to be looking at is we're going to be looking at distance versus velocity versus acceleration graphs. All right, we're going to use this kind of intro our acceleration unit here. We've been focusing a lot on these two, okay, this distance versus velocity. We're adding in the A word over here, okay, the acceleration. All right, so we know that velocity was a change in distance, and now we're going to be talking about acceleration as a change in velocity. All right, and the notes are on there online, but to start with, we're going to be looking at graphing. Okay, now to start with here, our first one, we've been looking at a lot of graphs that look like this. Okay, where we have our distance over here and our time, displacement over there and our time across the x-axis. We know that this thing has a positive velocity that is greater than 0. So here's our velocity. That's our time versus velocity. Silly. All right. Now this last stage is this object accelerating at all? The answer is no. Okay, let's say this is 5 per 1. So this is happening at 5 meters per second. Its acceleration is staying the same. It is not changing its speed at all. So that would be an acceleration of 0. Okay, that's everything that we've been working with so far has had an acceleration of 0. Today, we are going to talk about what does something like this look like. Okay, so when the distance is, the rate of change is increasing. All right, so let's say this is it's a very small hill, and you push an object and it starts off moving very slowly away from you, and then it's getting faster and faster and faster and faster as it's moving down there. All right, that would have a velocity that is changing. All right, so our velocity of things rolling down the hill is increasing. You all know that. All right, that's how that works in there, is that your velocity is going up over time. And then that's where this last graph over here is going to change. Okay, and when things are moving away from us and increasing speed, we are going to call that a positive acceleration. Okay, so we have a positive acceleration there. Thinking back to geometry, all right, the slope of our distance versus time graph was our velocity. The same is going to be true down here. The slope of our velocity graph is going to be our acceleration. Okay, let's do another example together. Here's our distance graph versus time. Let's look at something like this. Okay, first of all, what is that object doing? Think about that to yourself. That object is moving away from us, but it is slowing down, correct? It starts off moving very fast, but it's hitting the brakes and it's slowing down. So its velocity in this regard is positive since it's moving away from us, but is a decreasing velocity. Okay, so over time that velocity is going down, and so we would have a negative acceleration as a result. Okay, because like I said, it is slowing down, that object is hitting the brakes there. All right, last one I want to do with you, because I'm running out of room on my paper. We're going to have an object. We are going to throw it up in the air, and it's going to come back down. All right, we got a challenge one on our last one here. Okay, so object gets thrown up in the air and is going to come back down to Earth. What does our velocity look like? Holy cow. Our velocity is a tough one, isn't it? Let's draw it out here. I'm going to need to stop and think about it for a moment. Okay, so we start off with a positive velocity since it is moving away from us, but it is decreasing its speed, correct? So we start off here and it's decreasing its speed, and at some point that hits zero. If you're throwing a ball up in the air, you know that there's a spot where it kind of pauses, and then it is going to increase its speed in the negative direction coming back towards us there. All right, what does that look like for an acceleration? This is where it gets a little bit challenging, all right? Because we're looking at that and we want to really think that this graph looks as different than this graph is over here. But that whole time, the velocity is decreasing. So that is just a negative acceleration in there. All right, that's where it gets tough. The slope of this line doesn't change, right? It is a straight line, so that is a negative acceleration. So a few distance versus velocity versus acceleration graphs to kick off this acceleration unit for us today.